Hello, welcome to Geometric Virtual Learning. A special welcome to our new viewers. Lesson 3 on vectors. Prove that two vectors are parallel. Two vectors are parallel if one is a multiple of the other. And in an example, we can say 2a and half a are parallel because they are all components of a. And you can see that 2 is a multiple of half. Also, 3 into bracket a plus 2b and a plus 2b are also parallel lines because they are all vectors made of a plus 2b, and 3 is a multiple of 1. So talking about a multiple of the other, the notation we normally use is that if, for example, vector MC is a multiple of vector MP, then we say vector MC is equal to k vector MP. So it's very important that when doing vectors, your answers are simplified where possible to help you identify the true components of the vectors to confirm that two vectors are parallel to each other. So let's look at this question. Pause the video and read the question first. Okay, so we have a triangle OPQ and R is midpoint of OP, S is midpoint of PQ. We are supposed to work out the vector OS in terms of P and Q. And also to confirm or show that RS, this line, is parallel to OQ. So let's start with I, vector OS. Vector OS is simply vector OP plus vector PS. We know vector OP as P, so we are going along the vector, so it maintains the sign. And we know PS, given that S is midpoint, PS is half of vector PQ. So we need to work out vector PQ in order to work out half of that. So vector PQ is simply PO plus vector OQ. So to get to vector PQ is vector PO and plus vector OQ. Vector PO is going against vector P, so it has to be negative P. Then plus vector Q. Now that we know what vector PQ is, we find half of that, and that's what we have. Expand the bracket. So we are now going to replace vector PS with negative half P plus half Q. Then we simplify and factor out where possible. So if we simplify, we have half P plus half Q. And if we factor out half, we have half into bracket P plus Q. So that is our vector OS. So remember, in previous slide, we have vector PS as this. So that's what I've put on the diagram to help us with our working out. And also we had OQ, which is also given to us as Q. Now what we need to understand is that we are supposed to show that RS is parallel to RQ. We know, OQ. We know OQ already. So what we need to work out is vector RS. And RS is RP plus PS. We know vector PS from previous slide as this. And we also know vector OP as P. And R being midpoint of OP, then vector RP should be half P. That's where the half P comes from. It's half of vector P. So to work out RS, if we say RS is parallel to OQ, then OQ, which is the long line, should be a multiple of RS. So OQ, vector OQ is K vector RS. So first, let's work out RS. RS is vector RP plus vector PS. So you just have to write these down and simplify. Half P minus half P plus half Q, that gives us half Q. And you can see straight away, if we had not simplified our answer, it would be difficult to confirm that these two are parallel because different components now. But once the P's are cancelled out, you realize that they are all made of Q. And 1 is a multiple of half. In actual fact, if you double half, you get 1. So we can say that it is true that OQ is twice the length of RS, and they are all components of what? Q. That's how to prove that vectors are parallel. You just have to compare the components. What is made up of the vector? They are made of Q's. Let's look at example 2. So here we've been given vectors for AE as A plus 3B. Vector EB is negative A plus B. And we're supposed to work out the vector AB. Let's look at this first before we come back to the B part. Vector AB is simply vector AE plus EB. We are going along the same direction as it is, so nothing changes. We write them down and we simplify. So we can see that vector AB is simply 4B. Now the B part says that if vector ED, this portion, is a third of vector AE, and vector DC is already given as negative 1 over 3A, we need to show or prove that EC is parallel to AB. So if ED, we know DC already given to us, so we just put it down. And also if ED is a third of AE, then we need to multiply the vector AE, which is A plus 3B, by a third. And that's what we have here. That's the vector ED. So we can now work out EC and compare it with AB. And we know if EC is parallel to this AB, then vector AB must be a multiple of AC. And we know vector EC is ED plus DC. So you just have to just write exactly what we see. Going along the vector, nothing changes. So exactly what you see. So you have this minus that. You can factor out 1/3 and simplify your answer. Or you can choose to expand the bracket, simplify it, and factor out 1/3 the same way. If you've done your working out properly, you should end up with B. When you work this out, 1/3 of 3B is B. And you realize that they are all components of what? B. And truly, 4 is a multiple of 1. So it confirms that vector AB is 4 times the length of EC, and they're all made of B, and therefore they are all parallel. Simple as that. The last question on proving parallel lines is like this. So we have a trapezium. Vector AB is 12A, so you check with the arrows, everything to confirm. Vector AD is 3B. Vector AD is 18A. E is a point on diagonal DB such that DE, so this bit, is 1/3 of the whole line. Show by vector method that BC is parallel to AE. Okay. Now, if this is true, then it means that vector BC is a scalar of, or is K vector AE. We must work out both of them and compare their components. We know BC is vector BA plus vector AD plus vector DC. But vector BA, we are going against the vector, so it has to be negative 12A. The rest will be the same as it was before. So we have negative 12A plus 3B plus 18A. As usual, simplify your answer and factorize where possible. So vector BC is now 3 into bracket 2A plus B. We need to work out vector DB so that we'll be able to know what is actually vector DE. Vector DB is vector DA plus vector AB. and vector dA is going against the direction, so the 3b has to be negative 3. So that's what we have here, negative 3b plus 12a as usual. You factor out 3, so you have vector dB is 3 into bracket negative b plus 4a. Now that we know what vector dB is, we'll be able to actually know the vector dE, because we've been given that dE is a third of dB, as is in the question here. So we need to work out a third of this vector. And when you work it out, you have dE is equal to negative b plus 4a. So to continue with the proof, let's put down some of the answers on a diagram. We know dE is negative b plus 4a. So that's what we have, negative b plus 4a. And we also know BC from what previous slide is 3 into bracket 2a plus b. Now, if BC is parallel to AE, then BC is a multiple of AE. And this is how we write the notation. Vector BC is equal to K vector AE. So which means that we need to work out AE. And to work out AE is the same as vector AD plus DE. We know vector AD as 3b and DE as negative b plus 4a. So we work this out. Always simplify where possible. When we work this out, we have 4a plus 2b. But if we simplify by factoring out 2, this is what we have. Now let's confirm. They are all made of 2a plus b, the vector 2a plus b. So therefore they are parallel.